Hello everybody and welcome to this exam walkthrough for AQA GCSE Chemistry Paper 1. And today we're going to run through what you can expect from your first paper for GCSE Chemistry with information which is important and useful for triple and combined students alike. We're going to run through some key content, some tips and some strategies to apply to different types of questions, and also give you some exam questions for you to try throughout this video. So let's get started. So the first thing we need to go through is just a quick exam overview, and it's really important that you make sure you know which paper you're sitting. So if you are a triple science student, you will be doing your first paper, which will be 1 hour and 45 minutes and is worth 100 marks, and this makes up about 50% of your GCSE. Combined students, you will also be sitting your first paper, and this will be 1 hour and 15 minutes, just like your biology and physics papers, so a bit shorter than the chemistry triple students. And this paper will be worth 70 marks and is about 16.7% of your GCSE. Now, both exams are composed of the same types of questions, so you get some multiple choice, some short answer questions, some more structured questions, so it might be tables or fill in the gaps, and then some open responses as well. And all of these you would have done throughout your time doing your GCSE course, but we'll run through a few more of them today to give you the extra boost of confidence. So the first thing we want to do is make sure we're clear on the topics being covered. So in paper 1, you will be tested on C1, atomic structure and the periodic table, C2, bonding structure and the properties of matter, C3, quantitative chemistry, so that's a lot of your calculations and things like that, C4, chemical changes, and C5, the energy changes. Now, this is where your specification is your best friend, because it gives you all of the information that you need to make sure you know for each of these topics. So go through all the topics one by one, and if you haven't seen one already, I highly recommend you take a look, because that will give you an overview of what each of these topics comprise of, which can then be used to dictate how you go on revising for those topics. You also have your required practicals, and it's really important not to forget about your required practicals when heading into the revision period. I know that I often forgot about them when I did my exams all those years ago, but they're just as important as your core content in being able to answer a lot of your exam questions. So in this exam, you will have the following practicals that could potentially come up out of the ones that you did during your time doing your GCSE. So you've got your soluble salt preparation practical, and if you're a triple student, you've also got your neutralization practical, so those are your titrations, electrolysis, and then a practical on temperature changes in reaction. So there's 4 of them here, and then there's also 4 for the second paper as well. It doesn't mean that you won't get an exam question on a different practical, if that makes sense. That might be a slightly different method to the one that you did during your time at school, but it will probably have similar principles and you'll be given all the information you need. However, you could be asked about one of these types of practicals and you might need to be able to recall your knowledge from that time doing that practical. So I would recommend for each required practical that you revise the hypothesis, the independent, dependent and control variables, the equipment and their purposes, the method, and you don't need to have the method word for word in your head, but as long as you can know how to essentially get from A to B, how to get data which answers your hypothesis, that's what you need to be able to explain. And the data collection methods used, that's part of your method, but would be worth looking at independently. How you visualize data, so the graph type that you need to use, whether it's a scatter graph or a bar chart, for example, more likely to be in biology the bar chart, but you never know. And then finally evaluation as well, so your errors, your limitations, improvements that are common, or anything which you know in that practical could be a source of random error or systematic error. Make sure you kind of have an idea of these, because you will almost guaranteed be asked how to improve a method provided or some of these students' results, how to make them more reliable. And if you've got these in your head as you've been revising, hopefully it will make it easier to come up with those sort of suggestions as you're going through your exam. So your key ideas are what AQA have given us to basically say, As you go through this GCSE course, students will develop an appreciation for these key scientific principles. And these are things which aren't often kind of covered during a specific lesson. These are things that are run throughout your course, but it's really important to have these in the back of your mind when revising, because it helps you know how to link all of your topics together. So let's quickly go through some of these. So matter is composed of tiny particles called atoms, and there are about 100 different naturally occurring types of atoms called elements. So this is largely C1 material. Elements show periodic relationships in their chemical and physical properties. Again, we cover this in C1, however, these are both principles which are crucial to understanding all the other topics down the line. These periodic properties can be explained in terms of the atomic structure of elements, and atoms bonded by either transferring electrons from one atom to another, or by sharing electrons. So that's your ionic and covalent bonding from C2, which come up time and time again in all of your other topics. The shapes of molecules, so the groups of atoms bonded together, and the way that giant structures are arranged is of great importance in terms of the way that they behave. And when they say they behave, they mean the molecules. There are barriers to reactions, so reactions occur at different rates. So this is linking potentially more to C6 into paper 2, but could still be relevant to some of our topics and required practicals in this paper. Chemical reactions take place in only three different ways. So proton transfer, electron transfer, and electron sharing, which of course we learn the principles of again in C2, but run throughout the course. And finally, energy is conserved in chemical reactions. So therefore, they cannot be cannot be created or destroyed. And this is a founding principle in quantitative chemistry, which we have covered in C3. And as we went through in the biology or physics video, if you've already seen them, there are key ideas which run through across the sciences, and these will be the same for all three of your sciences, but this is kind of like how you develop that scientific discipline and having an understanding of basically how science works. So firstly, the use of conceptual models and theories to make sense of observed diversity of natural phenomena. The assumption that every effect has one or more cause. That change is driven by differences between objects and systems when they interact. That many such interactions occur over a distance without the direct contact. That science progresses through a cycle of hypothesis, practical experimentation, observation, theory development, and then finally reviews by other scientists. And that quantitative analysis is a central element of both many theories and of scientific methods of inquiry. And so I appreciate I've just given a long list there of very scientific and not very explanatory words, but this is the kind of stuff that you've, like throughout your science courses, have developed, and you would be surprised at how good you actually become at all of these. So take that in your stride, and remember that's what we're trying to do in these exams, and basically have the chance to show off how we appreciate these key ideas as well. So how are you assessed in these exams? Well, there are 3 assessment objectives which examiners and exam paper writers use to essentially assess you. And they look at different things. So AO1, you've got demonstrating knowledge and understanding of scientific ideas, techniques and procedures. So demonstrating that you know your stuff. AO2 is applying knowledge and understanding of, again, the scientific ideas, inquiry, techniques and procedures. So applying that knowledge that you've learnt to a different scenario. And AO3, analysing that information and ideas that you've been given to interpret and evaluate results or an observation, make some judgments and draw conclusions about some data sets you've been given, or develop and improve experimental procedures, which, as I discussed earlier, is something that comes up quite a lot. So those are our 3 areas, and you can see there, and we'll go through some more detail in a minute, but you can see that AO1 and AO2 make up the bulk of your paper, whereas AO3 is slightly less. But how do you know which one you're being assessed by? That's the question which has grappled many students, and often where pupils fall short, because they actually do know their stuff. If they see the mark scheme, they'll be like, oh yeah, I know that. Why didn't I write that in the first place? But it's because sometimes they don't know what the question's asking them to do. And that's where command words are a real crucial thing to get right. So command words are the identifiable feature in each question, which kind of tells you how to approach that question for a given topic. So your AO1s, where you're demonstrating understanding, and I will preface this by saying that this isn't 100% like a cheat sheet for knowing which question is going to be which assessment objective, but it just gives you a much stronger general idea. So AO1s will often be identifying, give or states, and then also your common command words you've seen throughout your time at school. So how, who, when, where, which, define, describe is often AO1 as well if it's quite a simplistic thing you're kind of talking about, and a name as well. So a lot of those mean very similar things and they might be used interchangeably. And then AO2 will be questions where you need to apply knowledge. So calculate is a very common one, particularly in chemistry and physics, because you are given some data or some numbers in the question. You've got to apply your knowledge of how to get to the correct answer using that information. Explain often will be a AO2, describe as well, and it's more likely to be a describe AO2 if you've been given some new context within a question and you need to, so for example, if you are talking about, or let's come up with an example here, you might be asked for example, to describe chromatography. So if you're just asked to describe chromatography just like that, you don't need to apply that to a specific set of solvents or solutes that you might have been given in a question. Whereas if you do get given like a proper example within the question, then you probably will need to be a bit more explanatory and you are applying your understanding of the process of chromatography to that context rather than just giving the steps of chromatography. You've also got use. So again, using the information provided, apply your knowledge to the answer, and complete tables as well, because often you'll have examples within a table which then you need to be able to complete that table for. And then again, you can have AO1, those ones in the AO1 table there come up as AO2s, but it's less likely, and again, it's just a general guide. And then finally, AO3 is your analysis and interpretation skills. So analyse, determine, predict, justify, evaluate, suggest, and plan. Those are your most common types of command words for AO3, and often there you will need to have done a bit of AO1 and AO2 as well. So often you find that it's quite rare to find AO3 questions in isolation, because usually you need to do a bit of AO1 and AO2 as well. But if you see any of those command words, it's a good indication that you need to be putting that extra bit of detail and evaluation into that question. So as I said before, AO1 and AO2 marks will make up each approximately 37 to 42% of your paper 1, whereas AO3 will make up 17 to 23% of those marks. So AO3 questions make up less of a bulk, but they are places where many students lose marks. So if you're going for those top grades or you've got a specific grade you want to do, don't want to miss out on those questions and those marks unnecessarily. So hopefully today we can kind of show you the difference between AO1 answers to AO3 answers and help you on your way to really showing the examiner you know your stuff. So let's start with AO1 questions, and as I said before, AO1 questions are recalling some facts, some definitions, structures, so atomic structure for example, and just your other key concepts as well, and it's really demonstrating that you know that topic. And there will often be clues within the question or within the wider whole part of the question, which as you'll know, you might get a total of 8 to 10, typically 7 to 10 big questions within any science exam, but each of them will have A, B, C, D subparts to it, and you need to be making sure that you link all of those parts of the question together, and there will be clues throughout the question which might help you get to your answer, but really just knowing your stuff as much as you can would really help you on your way to your AO1 questions. And you would be surprised at how much you probably remember from throughout your course. So really trust yourself, trust your gut, and do just go for it with these kind of questions, because there are quite a lot of them and they can be quick marks, because often there'll be multiple choice, often one word or short 1 mark answers. And so those kind of questions are the ones where you can spend 10 seconds and get 10 marks. 10 seconds and get 10 marks. You can spend 10 seconds or less and get 1 mark for it, whereas other marks might be harder to get. And also, you'll often see them within or alongside AO2 and AO3 questions. And if it is within a more complex question, this will be about demonstrating your knowledge first before applying it to an example or going into a bit more detail. And how do you answer them? Often it can just be one word or phrase. Often that's all you need. Otherwise, it might just be a very concise description or a definition. But really here, your focus is on being as accurate as possible and being clear. So keeping it short and concise can really help with this. So here are some examples of some AO1 questions which are both worth 1 mark. So we've got example question 1 here, which is state the relative charge of a proton. And for this question, you need to recall the basic subatomic particle charges from your atomic structure. And because you're only stating a charge, you only need that 1 word accurate answer, which is +1. So protons have a +1 charge, neutrons have a 0 for their charge, and electrons a -1, -1 charge. We've got question 2 here, which is name the type of bonding in sodium chloride. And for this question, you need to identify the correct bonding type based on the substances involved. So here we have a metal and a non-metal, which is an ionic one. So the answer is ionic. And you may be thinking here, oh, I've got an example here and I'm applying my information. Why is this an AO1 and not an AO2? Well, because sodium chloride is in the specification itself, the examiners basically expect that you'll be able to answer this off the bat with just recalling your knowledge, because it's a specific example that they've dictated that you need to know. There will be quite a few of those sort of examples throughout the specification. So again, specification is your best friend. Make sure that you're referring to that whilst you're revising to make sure that you are recapping all of the specific details that you need to know. However, if you didn't potentially remember recalling that, you can always, for this type of question, look on your periodic table, because you can find sodium and chlorine on the table and recognize there that it's a metal and a non-metal, and therefore be able to figure out it is an ionic bond. So for these questions, these are also AO1s, but they have multiple marks. So firstly here we've got describe the structure of a diamond. And so here you need to recall both the bonding and structure of a diamond. So using terms like covalent and lattice and stating how many bonds are kind of the things they're looking for here. So I've put here, for example, each carbon atom forms 4 covalent bonds in a regular giant lattice. So the regular giant lattice is what I would say is probably the structure, but the covalent bonds is also what they're looking for in how that structure has developed. So those are the 2 main points that you need for that type of question. We've also got name 2 products formed when hydrochloric acid reacts with magnesium. So here you need to remember that the general acid plus metal reaction, and just make sure you use the correct chemical names. So we know in this question, again, this is an example from the specification, magnesium chloride and hydrogen are produced from this reaction. And now you've looked at these 2 questions here. They're both worth 2 marks, but I've written a lot more for the first one than the second one. And that's because the first one was a describe question and the second one was a name. So I know there that the name literally just wants me to give the names of the answers, whereas describe needs me to go into a little bit more detail in order to get those marks. And so this question here is one of those examples where AO1 is a part of a question, and here it's an AO1 and AO2 mixed question. So explain why fluorine is a gas at room temperature, and it's worth 3 marks. So here I would start with your AO1 and use your knowledge of molecular substances to recognise that fluorine is a simple molecular substance, and then your AO2 is applying this to the property of being a gas. So weak intermolecular forces to low boiling point and gas state. So here's my answer. There are weak intermolecular forces between molecules which require little energy to overcome. So we know that a simple molecular substance has weak intermolecular forces between each other, and that is linked to having a low boiling point and therefore being a gas at room temperature. So now it's your turn. So pause this video here and go to the AQA Chemistry Revision Hub, where you will find some AO1 questions supplied through the exam builder. So all of these questions will be AI marked and feedback given instantly, and just have a go and see how you get on. The results won't be saved or shared anywhere, so just have your best go, and remember this is all just for your benefit. And then once you finish that, come back to this video and we will go through some AO2 questions. Okay, great. So now it's time to go through some AO2 questions, and AO2 assesses your ability to apply your knowledge and understanding to a new context. So you're using relevant examples to show you understand how a concept works in practice. And this is time to show off your scientific knowledge and show that you fully understand it. So a question, again, might be multiple choice. In fact, all of these, AO1, AO2, AO3, they could all be multiple choice. One word or short 1 mark answers can be possible with these, and we have some examples. There could be part of a question alongside an AO, that should say AO2 and AO3 points, so AO1 and AO3 points, sorry. So it could be embedded in a different type of question, and if it is part of a more complex question, you may need to define or explain or describe something first before you go into more depth or come to a conclusion, for example. And so how you answer it, consider the amount of points that you need to make first. So is it a 2 mark, 3 mark or 4 mark answer? Does it tell you if you need to relate it to an investigation or a case study? And then also you need to consider whether you need to demonstrate the knowledge first, so AO1 stuff first, before applying it. And so just think about what you've learned throughout your course and apply it to the situation that you've been provided with. So here are some examples of some AO1 questions. So question 1, explain why graphite conducts electricity. So here it's different to the diamond question because you need to explain how the structure of graphite allows it to have a certain property. So using your knowledge and understanding of bonding and structure, explain the conductivity in graphite. And if you remember, graphite has delocalized electrons. So that's our answer. It has delocalized electrons. It's only 1 mark, so you don't need to go into a deeper explanation there because it's given us in the question that it conducts electricity. So our answer essentially would be it has delocalized electrons, therefore it conducts electricity. But you only need to keep it as simple as that. You can write the full sentence if you need to, but it's not necessary if you're running short on time. Example question 2. Iron reacts with oxygen to produce iron 3 oxide and balance the equation. So this will be a question that will almost definitely come up in your exam at some point. So you need to use your knowledge of chemical reactions to recognise the formulas of the reactants and products here. So iron, oxygen and iron 3 oxide, and then apply the law of the conservation of mass to balance the equation. And here is the answer. So you need 4 iron atoms for 3 oxygen molecules to produce 2 molecules of iron 3 oxide. I'm sure you would have done lots and lots of practice of balancing chemical reactions throughout the last couple of years. And yes, it's one of those where you're almost guaranteed to have that kind of question come up, particularly in paper 1. So I would say practice, 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 and you will be fine. And then question 3, what is the electronic structure of an argon atom? Now we've been given the atomic number and the mass number within the question here. It might not necessarily do that. I've done that here for the purposes of showing you this example, but usually you'd be able to find all of that information on your periodic table in your exam. So don't forget to look at your periodic table. So what you need to do here is apply the rules of electron shell filling that you would have covered during your lessons. So remember that in the first shell of the electron shell orders of an atom, you can only have 2 in the first shell, 8 in the second, 8 in the third, and then the rest of it's not relevant to this question, but essentially it means that we can basically make sure we add up until we get to 18. So 2 in the first, 8 in the second, and 8 in the third takes us to 18 electrons in total, which gives us the answer 288. And so here are some more questions which are multiple marks for AO2s. So the relative formula mass of a metal carbonate is 84. Calculate the relative atomic mass, the AR, of X. So X is this one here. So what you need to do here is recall how to calculate relative formula mass using the AR values, which you will be given in the question, and rearrange to solve and find the missing AR, so X. So firstly, I would figure out what is your total MR for the information that you do have. So oxygen atoms, we've got 3 of those, so 3 times 16 is 48. Carbon atoms, we've just got the 1, so that would be 12, because we've got the atomic number there would be 12. And then 48 plus 12 equals 60, so that is the carbonate part of this metal carbonate. And we know that the relative formula mass is 84. Therefore, the difference between what we've got so far and the final relative formula mass is 24. And then you refer to your periodic table, and then you can find the AR, which matches 24, and that's that of magnesium. So X equals magnesium. So you can see that's 4 marks for that question. Each of these sections, apart from the carbon atoms there, being worth 1 mark each. And then question 2 here, a bit different. Describe the limitations of using a ball and stick model for a water molecule. So here you're applying your knowledge of particle models, and think about, we've got an example here, and I'm pretty sure in the exam question that this came up in, whenever I've seen it, it always has a picture of, or a diagram rather, of the model in question, and think about what is unrealistic or misleading in this model. So there could be things here such as, so it's not to scale, so this isn't the size of the bonds or the atoms relative to each other necessarily. It's not 3D, and atoms and molecules are in 3D. The incorrect arrangement in space, so this isn't necessarily what it will look like in space. So it could be seen as misleading. There's no electron shell shown, so you can't see which electrons are bonding where. The size of the atom is incorrect, of course, and the atoms are separated in this molecule in a way which they wouldn't be in the actual molecule. So there are many things that you can talk about here, and just as important with the different models and diagrams for showing electrons and molecular structures, you need to make sure that you know the limitations of representing them in this way as well, because that really shows that you understand how those molecules work as well. And again, here are some questions, AO2 questions, where AO2 is just a part of the question. So example 1 here, explain why the early periodic tables place iodine with an AR of 127 before tellurium with an AR of 128. But then Mendeleev placed tellurium before iodine. So why did they switch? So here you need to recall how elements were originally arranged, which is an AO1 scale, and then apply that to how Mendeleev used patterns and properties to this example. So in my example answer here, I have said that the early periodic tables were arranged with elements in order of their atomic weights, so 127 and 128. Iodine has a lower atomic weight than tellurium. However, Mendeleev placed iodine with the elements of similar properties, which basically caused him to swap them around. And that's all you need for that 3-mark question. Question 2. Explain why copper is formed at the cathode during the electrolysis of its salts. So you need to recall the charges of ions and electrodes, so an AO1 principle, and apply that knowledge to explain the movement of ions, AO2. So here the answer for 2 marks would be copper ions are positive, so the copper ions are attracted to the negative cathode. Here we've also got a graph question, and I've put this one in here because in a chemistry paper 1 exam you're again very, very likely to be given a draw a graph question, and these will be AO2. The table here shows the change in temperature during the reaction between dilute sulfuric acid and potassium hydroxide solution when different volumes of dilute sulfuric acid is added. Draw a graph to show the results. You should label and add the scales to the axis, plot the results and draw a line of best fit. And there's a high chance this is how this question for you will be structured. I can't guarantee it. This is typically how it looks. So you've got your data here, and then you'll be given the space that you need to draw your graph. But then it is a case of plotting them accurately. There's a tiny bit of margin for error, but you want to be making this as accurate as possible. Make sure you choose axes which are appropriate, so it takes up as much of the space that you've been given for your graph as possible. If the labels aren't there, you need to make sure you add them with the correct units, and plot your data and draw that line of best fit with hopefully either all of them being on the line. If not, at least equal numbers on either side of the line is usually your best shout for these kinds of questions. So again, now it's time to pause this video and have a go at some questions yourself. So if you click on the AO2 link below this video on Revision Hub, you will find the questions, have a go, and then come back for some AO3 questions. So AO3 questions are about analysing a situation or an experiment, and you might need to break it down and explain what's really happening, or potentially evaluate the effectiveness of something. And if you have been prompted to, you need to justify decisions or opinions or reasons that you've given for something, and then draw conclusions based on that evidence as well. You won't need to be doing that for every single question. That's backing yourself up. That won't be necessary every single time. Depends on the length of question, but if it's a 5 mark or a 6 mark, often you'll need to do so. So what might the question look like? You might need to analyse a method or some data, or give your opinion and back it up with some evidence, which is less likely in chemistry, I must say, more likely in biology, but it could potentially come up either way, less likely. And that it could also be a part of a question alongside an AO1 or AO2 point. And so for these questions, I'd approach it with considering the amount of points you need to make, again, similar to AO2, and does it ask you to relate it to a figure or a practical given in the context of the question? It will usually explicitly tell you if you need to, and if it does, make sure you do, because you will not be accessing all of those marks if you don't make a direct reference to something in a figure or in a practical method, in a data table, etc. If it's asked you to do that and you don't reference something, you definitely won't be getting all the marks. And then also you need to consider whether you need to demonstrate knowledge first before applying it again to the context provided. And always back up your points and remember to answer the question. So here are some examples of some AO3 questions. So example 1, a student wants to make a fair comparison of the reactivity of metals with hydrochloric acid and name 2 variables that must be kept constant. So this is going back to our required practicals, which we looked at earlier in the video, and often these will be related to AO3 points because you've been given a method. It will usually be in more detail than this, and you need to go ahead and identify some control variables in this instance. So you're evaluating how you can make this investigation fair. So think about what could affect the results other than the metal type, in this case used to identify the key variables. So the answer here could be the mass of the metal, the surface area of the metals used, concentration of the acid, so the hydrochloric acid, the volume of this acid, or the temperature of this acid. These are the 5 which are probably the most main ones that you can come up with, and you basically need 2 of these to get the 2 marks. So for question 2 here, you need to predict the reactivity of beryllium compared with magnesium and give a reason for your answer. So here the give is in the context of justifying why you have given that prediction. So firstly, analyse the atomic structure and reactivity of beryllium and magnesium. So the starting point here will be your periodic table. So in your mind, compare some shielding, the nuclear charge and the atomic radius, and then use this to explain how easily an atom can lose electrons. Think about this answer quite clearly before writing it down, because there's quite a lot to consider. But here's an example of an answer which would be 2 marks. So in this example answer here, I've said beryllium is less reactive because there is a greater attraction between the nucleus and the outer electrons. So for this one here, this section, there's only these four lines here, would be worth 2 marks in themselves, because I've predicted the reactivity compared with magnesium and I've given a justification. I only needed 1. I could have also said that more energy is needed to remove electrons, or the loss of electrons is more difficult in another phrase. The outer electrons are closer to the nucleus in the magnesium, or there's less shielding. So here are some AO3 questions which are worth multiple marks. So question 2 here suggests 2 safety precautions that should be taken when heating magnesium and oxygen. So here you need to assess the risks and apply some safety knowledge So identify hazards like a bright light, high temperature and reactive metals. These are ones which you should be able to recall about magnesium. In a wider part of the question, there may have been reference to this, but it's the kind of thing which you might be able to remember as well. And then also you need to suggest appropriate precautions to reduce these risks during a practical. So you've identified those hazards, and the main part of this question is asking you to create the safety precautions, but you need to identify the hazards before you can possibly do your AO3 analysis and application. So some possible answers here could be to wear safety goggles, wear heat-proof gloves, use tongs, tie hair back, look through blue glass for the bright light of magnesium, and or potentially do not look directly at the burning magnesium. And then for the second question here, it's a bit longer, but green copper carbonate and sulfuric acid can be used to produce blue copper sulfate crystals. So this is related to practical 1, which was making salts. Excess copper carbonate is added to sulfuric acid. So give 3 opposite observations that you would make. So here you need to think about what might happen visually. So you might have colour changes, gas release, solids disappearing or remaining. Focus on what you saw during your experiment, or what you would have expected to see if you can't remember it, and apply it to what would happen during this reaction. So the mark scheme here is quite extensive, and you could basically have any 3 from the following. So a green solid or powder, colourless solution, a blue solution forms, copper carbonate disappears, fizzing or effervescence or bubbles, stops fizzing, and a solid powder or copper carbonate is left at the end. So these are points which, if you wrote them just like that, it would be quite hard for examiner to really know what you're kind of talking about. So I'd really recommend here just to write all of this in the context of your answer. But those are basically the key points that you would need for those marks. So now it's your turn. So pause the video once more and have a go at some AO3 questions supplied just below, and then we're going to come back and look at some extended answers quickly before I set you on your way. So finally, let's look at some extended answer questions, and typically these will incorporate AO1, 2 and 3 all together, but it can really range from 100% AO1 to equal parts of all 3 to 100% AO3. But really it's showing that you've got ability to demonstrate your knowledge or apply it to a real life context, practicals or case studies provided. It's very similar to the other questions that we've seen, but it's just your ability to write this in a bit more of a longer format. And so these will be 6 marks. And I would always start with underlining the key information from the question, and it can help to provide a brief introduction and conclusion to summarise, and if it helps you then that's great, but it's not necessary. However, what is necessary is that you elaborate your points in explain and not just state, and use those command words as clues as well, because that will be your guiding light to composing your answer. Keep it well organised and easy to follow, and only include the relevant information, and only use visual elements when you absolutely would see that they're necessary. But usually it's better just to stick to words. You can briefly plan your answers out as well, just to make sure that you include everything that you know of the topic. But if you do this and you don't want that plan marked, make sure it's crossed out completely. Otherwise, an examiner would be able to mark it, and it could cause confusion with your answer as a whole. So let's look at an example here. So describe a method to investigate how temperature changes when different masses of ammonium nitrate are dissolved in water. You do not need to write about safety precautions. So immediately forget anything about safety precautions. It's not going to get you any marks. But here we're describing the method. So this is similar to methods that you would have done during required practicals. And essentially for your level 3, you need to create or describe a plan which would lead to the production of a valid outcome. So the steps are identified and logically sequenced. So you don't start with like how you're collecting data and then go to your variables at the end. You really want to be writing about your hypothesis and variables at the start, and then your data collection throughout your method. And so level 2 might be that your design would not necessarily lead to a valid outcome. So one which might not be controlling the control variables, or might not be measuring something which is reliably measured. Most steps are identified, but the plan is not fully logically sequenced. And then finally, level 1, the design plan the examiner can see would not lead to a valid outcome. And it does identify some relevant steps, but the links between the steps and how they relate together is not very clear. So that would be giving you 1 to 2 marks. And so the examiners base this off the indicative content. So these are the information, the mark scheme that the examiners are given, but they need to basically use that, look at your answer and figure out from there which level it is in and then what part of the level your answer is worth. So some of the steps for this one would be using a suitable container, such as a test tube, using insulation to control the temperature, add water, measure the initial water temperature, add stated mass, e.g. 1 gram or 1 spatula, stir, measure the final temperature of the solution, calculate the temperature difference or determine graphically, repeat with different masses, repeat with the same volume of water, and then to access level 3 there must be an indication of how temperature change is determined using different masses dissolved in the same quantity of water. That may have not made much sense reading it out like that. This is where it's really important to guide your examiner through your understanding of the question, because if you were to simply write all of those, they probably wouldn't give you a level 3. What you need to do here is describe your method and just be a little bit more elaborative, and it can really help if you've revised your required practicals, and this would really help you on a question such as this. So here are some examples to give you a little bit more of an understanding of how you can apply that. So let's look at level 1 answer quickly first. So put ammonium nitrate in water and see what happens to the temperature. Use a thermometer. Do it with more and less powder. So this is a level 1 answer because it does contain some relevant ideas. So it is worthy of credit, but it lacks clarity, some structure and a sequence really. And there's no indication of repeating steps, controlling the volume used, nor some proper data collection. And it doesn't explain how to calculate or interpret that temperature change. You've got your level 2 answer here, which is a little bit more elaborated. So put a known mass of ammonium nitrate into a test tube of water and measure the temperature before and after. Stir to dissolve. Repeat with different amounts of ammonium nitrate and compare the temperature changes. So this one does include key steps such as the mass, temperature, measurement before and after, and also the importance of repetition. It does refer to stirring, but there's no mention of insulation, the use of specific tools or equipment, or using the same volume of water throughout. And the steps aren't really necessarily logically sequenced. So it is mostly correct, but there is some missing detail and a structure to be deemed a valid scientific method. However, when you look at this level answer 3, you can see that some of this is in there. So use a test tube or beaker with the same volume of water each time, e.g. 50 centimetre cubed. Measure the starting temperature with a thermometer and add a known mass of ammonium nitrate, such as 1 gram, into the beaker using a spatula. Stir until fully resolved. Record the final temperature. Calculate the temperature change and repeat with 2 grams and 3 grams of ammonium nitrate. Keep other variables constant and use insulation to reduce heat loss. So here we have been given a clear and structured method which refers to stirring, and all of the key steps are included. So volume control, accurate measurements, stirring and insulation. It is also logically sequenced and leads to a valid outcome and essentially shows an understanding of controlling the control variables as well. So overall, this is an excellent answer demonstrating some planning and scientific thinking, though if I was to say where it could be included, I would say to be a bit more elaborate on your independent and dependent variables and how you would record your results. So now it's your turn. We have a few extended questions for you to try, which you can find below. There are 3 of them, and you can do as many as you would like and see how you get on. And you can also practice them as many times as you like as well and see how you improve over time. But that's it from me. Thank you very much for spending this time with me to go through the first paper for AQA GCSE Chemistry and Combined Science Trilogy. And I really hope you find this valuable. Please go to AQA GCSE Biology Revision Hub, as well as the physics one as well, where you will find videos similar to this, but applied to those different sciences. So have a lovely day, and hopefully I'll see you in a few weeks to go through paper 2. Bye.